inside the line are appropriate. That cell. This one's faded. There's a cell. Here's a cell that's kind of squishy. Yeah, it's a blood vessel. Okay. Now, I was showing Victoria that there are a lot of glands down here. Now, these are not blood vessels. I know that these are glands because they don't have a simple squamous lining. The lining cells are thicker, a little more cuboidal, or in some places almost even columnar. Okay. Look here. This is a cut, your secretory unit. Because the cells are nice and round, it makes me think that this is a serous type gland. There's a lumen here. See, there's little granular secretions in there. Okay. So, and there's a bunch of them. So there's a bunch of cross sections, almost like we cut through a bunch of grapes. So these are probably alveolar glands in terms of structure. And they're going to empty through a duct to the surface, and that's the duct that shoots them up to the surface. You don't see the lumen in it. Well, here's a kind of a longitudinal cut that reaches down to these glands. And of course, the wall of the trachea is supported by cartilage, and that's what we see right here. This is hyaline cartilage. Look, the surface epithelium will look for space, because it's going to line a space, either the exterior of our body or some type of cavity inside of our body. So if this is the space, then here's the epithelium. Let's look at it closely. What type of epithelium is this? Yeah. So you see multiple layers of cells. The basal layer here is kind of cuboidal, but as it moves up, the nuclei become flattened. And then the nuclei up here disappear. As the cells lose all their distinguishing characteristics, they just become a bag of keratin, one connected to another. So these are like strands of keratin that are beginning to break down here. But this is keratinized stratified squamous. Now, these structures here that have a lumen and are lined by simple squamous, these are blood vessels here, here, and here. But this is not. This is a duct that's extending down. Now, these ducts, okay, kind of move in and out of the plane of section. So here, in this longitudinal cut, the beginning part of the duct is within the plane of section. But if it moves toward you or moves to the other side, then you don't see it. It disappears because it's not within the plane of section. But it's going to eventually move down and connect with sweat glands. That's a duct of a sweat gland. Here's another duct of a sweat gland right here. And we're only catching a little piece of it in the particular plane of section. So let's look and see it. Look at it better. Okay. So this particular duct of the sweat gland has two layers of cells. 1, 2, 1, 2. Okay. And ducts of sweat glands typically considered to be stratified stratified cuboidal. Here's one cell, here's the next. They're not flat enough to be squamous. So this is typically your stratified cuboidal epithelium has 2 or at most 3 layers of cells. And so these ducts of sweat glands typically have 2 layers. The sweat glands, when you reach the secretory portion, Okay, you see multiple units here. And these are actually all part of the same secretory unit. Because what happens with a sweat gland is this. These are simple coiled tubular glands. So from the surface, you have a duct comes down and gives rise to this coiled secretory unit. When you cut through it, right into the slide, you get 1, 2, 3, 4, maybe 5 different cross sections. And so those 5 different cross sections kind of look like this, perhaps. Like 4 or 5 different structures, but they're all part of the same secretory unit. You have to convert this 2-dimensional image that you see on the slide into a 3-dimensional image that exists in real life. So you can see that there are multiple sweat glands or clusters of glands here. Okay? Now, typically the secretory unit consists of cells that stain a little bit lighter than the duct. These fragments here are part of the duct that's going to extend upward. Okay. So let's take a little bit closer look here. So question for you. Put this in the center. Is this a sweat gland? No, this is a simple squamous epithelium here that's lining a little bit, that's got red blood cells in it. So this is a little arteriole. On the other hand, this here, that has at least 2 layers of cells here lining a smaller little here. This is a duct that's extending up. In fact, this is part of the same duct that this is part of. It's just weaving in and out of the planar sections. These are tiny blood vessels, simple squamous epithelium surrounding the endothelium. In fact, you can see some other blood vessels like here, the simple squamous epithelium. Look at your epithelium to identify structures. Does anyone else have a skin slide for me? Do you have a skin? Let's take a look. I know you have one. No. Here it is. Meissner's corpuscles are in skin. All right, so let's look at this one. See a blood vessel right there. Lined by simple squamous. But again, here's stratified squamous epithelium. These are clusters of sweat glands. Now, this is the secretory unit here. You see 1 layer of cell, there's a nucleated cell right there. Okay. Here's, again, these aren't well defined, but these are nuclei. Here's a second set of nuclei here. So this is a secretory unit. This is actually a darker staining part of the duct. And again, you can see the duct has 2 layers of cells, 1, 2. So this is stratified cuboidal. So both the secretory unit and the ducts are stratified cuboidal. Immediately when I look at this line, I see villi. So it tells me, okay, this is a small intestine. goblet cells. Lots of goblet cells. Now, although you don't see the basement membrane well, it's somewhere around right here. And you see a single layer of nuclei, oblong nuclei, that kind of line up. So this is a simple columnar epithelium. Here's that brush border. Nice and homogeneous. It's like a Doppler band that's on the surface. This is a goblet cell. And you can see in the lamina propria down here, you have lots of lymphocytes. Some of these lymphocytes are trying to move up toward the surface. There's a lymphocyte there. It's not like this one here. The nucleus looks different. Okay. This is lamina propria. On the other side is the other side of the villus here. And there's that brush border again. Make sure you can differentiate a brush border from cilia. Now, sometimes when you're looking at simple columnar epithelia, if you don't look at enough of the slide, some of the cells will be packed upon each other, and you can begin to look at some places like, oh, maybe this is a stratified epithelium. But you have to look at an area where the tissue is cut at a 90-degree angle, so you have perfect alignment of the cells, and then you recognize, well, this is a single layer. Now, we said that one place that you find stratified columnar is within the larger ducts of salivary glands. And in fact, the larger ducts of different types of glands, including mammary glands. Okay? And so, if I look at this tissue, this is a salivary gland, I know right off that this is a blood vessel because it's got an endothelial lining. It's got a simple, look at the flat nuclei here that are lining the liver here. So this is a blood vessel. Whereas this structure here has a thicker epithelial lining. That's where we're going to focus here, this large structure here. And you can see at least two layers of cells. The basal layer have nice round nuclei. The surface layer of cells are more elongated, and some of the nuclei are beginning to elongate. So this is a stratified columnar epithelium. By the way, this blood vessel here, you can see the red blood cells. Everybody with me? So we've seen simple squamous, stratified squamous, simple columnar, stratified columnar. We've seen simple premortal and stratified premortal. Let's look at our, and we saw pseudo-stratified. Let's look at transitional. So here's a space here. So this has to be the epithelium that lies in here. See if we can take a close look at this epithelium here. And I can tell even at this low power that this is stratified. You have multiple layers. Okay. So eyeball this. So you get like 1, 2, 3, at least 4 different layers of cells. And if you notice, as you go from the basal layer to the surface, the nuclei haven't flattened. Now, some of the surface epithelium has been stripped a little bit, but the nuclei at the surface is still nice and round. In fact, the cell almost has a dome-shaped appearance. So this is transitional. Now, this tissue is distended. You don't see any folds. I wonder if part of it does fold. Let's look. See some folds here. represent a bladder. Does someone else have a bladder? Here's what I mean by folds. You see the surface tissue is forming these peaks and valleys here? Okay, this is equivalent to rugae. Okay, because what's happening is that this cavity or space is contracted, it's not unsteady. Once this bladder fills with urine, you lose these folds. Okay, the epithelium becomes thinner. You can see that there are multiple layers of cells, and look, the cells at the surface are still nice and rounded. You got some mucus here, or some of these are cells that are not cut through the nucleus. This may well be a cell, but it's not sliced through the nucleus. This one you can see the nucleus. Okay? But this would be a transitional epithelium. Just like all that and appropriate. The connective tissue is vascular, so you can see blood vessels. Okay. Let me show you some glandular epithelium. This is a slice through the parotid gland. And structurally, these are exocrine glands. The parotid gland produces secretions that are carried by a duct into the mouth. And here is a cut through one of these alveolar secretory units here. And I want you to notice two things. Number one, the nuclei are rounded. And the cytoplasm of the cells, like this cell here, is darker stained. So this is a serous gland. You can see those lysozyme granules. Here's the lumen of the secretory unit. So the parotid gland has lots of these little secretory units. Here's another one. But these are serous glands. They're darker staining, they have rounded nuclei, they have granules, they produce enzymes. Okay? These secretions that are carried by the lumen here are going to become part of saliva. They're going to contain an enzyme, salivary amylase, that will begin to break down carbohydrates. Now, these lighter staining structures here are ducts that are going to carry the secretions. Right? But this is all glandular epithelium here. These cells make up glandular epithelium. And they're part of exocrine glands. Look at this duct here. It's got stratified cuboidal epithelium. A double layer of rounded nuclei. Those are not blood vessels. Now, those smaller ducts will eventually empty into larger ducts. So if you look around the tissue some, you may find some larger ducts that represent the anastomosis. Like, for instance, here's a larger duct here. On the other hand, this right here is a blood vessel. It's elongated. This is a longitudinal view, but if you look at the lining, the simple squamous epithelium. All right, let's look at this other salivary gland. a mixture. This is a serous secreting gland here, where the nuclei are flat, and the cells are very light staining, eosinophilic. And right next door is a serous secreting gland, where the nuclei are rounded. You see granules within the darker staining cytoplasm. So this happens to be the submandibular gland, where you have a mixture of mucus and serous glands. This is going to be a duct. So these larger structures here lined by a thicker epithelium, these are ducts. And that particular duct looks like it's surrounded by a simple cuboidal epithelium. If it gets a little larger, it may become columnar. Here's a larger duct here. This one looks like it might even be cuboidal to columnar. And that's just some secretory debris. Just look at one more salivary gland. This is the sublingual gland. If you look at the sublingual gland, it's mostly mucus secreting secretory units. In other words, here's a secretory unit here. The cytoplasm is very light. The nuclei are compressed. Here's another secretory unit. Here's another secretory unit. Yeah, so the sublingual gland is a salivary gland that has mostly mucus secreting glands that lubricate within the mouth. This would be a duct. I'm going to show one more thing. And this next one, I'm going to ask you what you're saying. Is everyone able to follow? So here is the lumen here, and it's lined by what type of cells are these? What type of epithelium? Hold on. What do you think these are that extend down, that invaginate down?
Goblet cells.
Oh, you have a lot of goblet cells, but what are the structures? Not the cells, but what are the structures that extend down? Like this. In other words, the epithelium lines the surface, and then some of these epithelial cells invaginate down like this. What are these structures that invaginate down? Those are glands. They just extend down from the surface epithelium. They connect to the surface epithelium. And the shape of these glands, the structures, that these are simple tubular glands. In other words, the duct doesn't branch. Down here, they're reaching down to these secretory units down here. You don't see the connection so much. But these are just simple, straight tubular glands that are extending down to the foramen propria. Okay? And yeah, you're producing, these goblet cells are producing mucus. That's going to help facilitate or lubricate the feces to help facilitate its evacuation. That's what happens within the colon. You have all these goblet cells. You have more goblet cells in the colon than you have in the small intestine. There's buku goblet cells because you have to lubricate the fecal matter so that it moves and glides easily into the rectum and then out of the body. So yeah, these are straight tubular glands. Because they're so straight, you don't see a bunch of cross sections like you would see with a coiled tubular gland, like a sweat gland. Okay? All right. I'm going to show you a couple of different things now.